This video explains about dependency inversion principle and how can we achieve dependency inversion through our code. Without getting any further delay, let's get into the topic. Dependency inversion principle states high-level components should not depend on low-level components. Both should depend upon abstractions. And also, abstractions should not depend upon details. And even details also should depend upon abstractions. If you don't understand anything, don't get confused. I will explain it clearly using the code. But to explain dependency inversion in simple words, we always need to keep the high-level module and the low-level module as loosely coupled as possible. That's the key concept behind the dependency inversion principle. Usually, the application depends on the business logic layer, and this in turn depends on the data access layer. Most of the times, we see these are tightly coupled, and this lead to heavier maintenance of the code. But how it should be? The main motto of dependency inversion principle is to achieve loose coupling. So how can we do that? We should have an interface, otherwise called as abstraction, place an intermediate or maybe mediation role between the application layer and the business logic layer. Similarly, there should be some other interface or abstraction play the mediation role between business logic layer and the data access layer. This is how we should design a program, and thus we can achieve the loose coupling. So let's see how can we achieve this using our code. Let us look at this invoice class. You can see we are initializing this invoice class and assigning the workbook path and the sheet name and invoking getAllInvoiceDetails method. And the getAllInvoiceDetails method uses pandas to read Excel information and return the data frame of invoice details. And we have three more methods, namely getInvoiceDetails by invoice number and getRowID, and the last one being updateInvoiceDetails. So what do we do in getInvoiceDetails by invoice number? We are trying to extract the details of a specific invoice here. Similarly, whenever we pass an invoice number, we are trying to extract the row ID of that particular invoice number using this method. And finally, the update invoice number itself states that we are going to update the details of invoice. Now let's go into the client application code. What we are doing here is we are instantiating invoice class, and we are trying to display all invoice details at first, and then we are updating the invoice details by passing the invoice number and the amount. For example, it is 1250 here, so let's mark it as 500, and also trying to see what are the invoice details for the invoice number 1004. Let's run the. Let's get back to the invoice code now. If you observe, we are instantiating the object in the same code, and at the same time we are also accessing the data in the same piece of code and doing the business logic, everything here itself. So what we are doing here is we are making the logic and the data components tightly coupled. So whenever we want to make changes to the data component alone, we have to make changes to this particular code, because the changes will definitely impact the business logic. So to handle this challenge, we have the dependency inversion principle defined. Let's see how can we handle this. We are hard coding the workbook path and the sheet here. So to overcome that, what we have done is we have moved this configuration to INA file where we can assign the path and the sheet name as key value pairs. And we have defined iData collection interface. Basically, it's an abstract class. So as we have made all the members as abstract methods, we are calling it as interface. We are defining a data collection class by implementing the iData collection interface. Okay. So what we are doing here is when we initialize the data collection class, we are making use of config parser to read this mypy.inf file and extract the workbook path and the sheet name. And also we are implementing the get all invoices, get OID, update invoice details methods as per the old logic. The data collection class acts as a data access layer. But as discussed earlier, we should never let the application layer directly access this in order to implement the loose coupling. So what do? We have implemented iRepository interface where we will get all the invoices and update the invoice details. And at the same time, we have defined repository class which implements iRepository. So what do? When we initialize the repository class, we assign the collection property as the data collection object. So with the help of the self.collection, we are accessing the get all invoices details method from its data collection class. And similarly, we do the same thing. So we are going to access the update invoice details from the data access layer through this repository container. Are we implementing any complex logic here? We are simply routing the request to the data access layer. This is the important thing that we should observe in this area. So now the repository acts as an abstraction because we are not relying on details of data completely. Okay, and at the same time we have defined invoice manager interface and the classes. So even the invoice manager has got three abstract methods, namely get all invoices, update invoice details, and get invoice details by invoice number. And the invoice manager class implements iInvoice manager interface by initializing repository object. And we get the invoice details by using this particular repository object, same as in the repository. Here also we are not doing anything that complex. We are routing the request to the repository class. We are adding one more functionality by adding a method called get invoice details by invoice number. As it is a business logic layer, so we have defined some logic here, so that will get our job done. And now we have our client application, so which is interacting with the invoice manager. Using the invoice manager object, we are invoking the get all invoices method first as in the previous implementation, and also updating the invoice details. Suppose if I want to make it as some 260 now, and we are going to get the details of all the invoices after update and then the specific invoice number which we have updated. So now let's run the. You could see initially the amount is 500, but later we have updated the value as 260, and when we retrieve the invoice number details for that updated list, we are getting 260 as the updated amount. So the implementation is all same, but we have achieved the loose coupling here. So this is how we implement the dependency inversion principle. Now let's observe what we have done. So we have the client application and the data access layers. And the client application is called the high level component, whereas the data access layer is called the low level component. So what we have learned about dependency inversion principle, the high level components and the low level components should not depend on each other, and they should depend on only abstractions. If you observe, right? So client application is depending on the invoice manager, and the data access layer is depending on the repository. And these abstractions didn't depend on component details. Did you see? These abstractions has got something to rely on the details. The data access layer is utilizing the repository to serve the client application basically, and similarly the client application is utilizing the invoice manager to send a request to data access layer or update the data access layer. So the details are also dependent on abstractions, and abstractions never depended on details here. If you observe, right, so these abstractions, invoice manager and repository, what they have done is they have removed the dependency, and we call that as dependency inversion. When we are inverting something, so we call it as inversion. And now these components are loosely coupled. Now I strongly believe you have a clear picture of what dependency inversion principle is. And in case if you have any queries, please feel free to comment your query in the comment section. I will definitely answer your query. Thank you for watching. Have a wonderful day.